Okay, so we have one more talk left, and this one is from Trond Hjorteland, who's going to do a talk that is again more towards the complexity domain. Hi, Trond.
Hi.
Hi. And I've seen a longer version, so this is kind of a challenge to do it in 20 minutes. I've seen a longer version of similar talk, and it's going to be about open social technical systems and modularity, which is super exciting, very interesting, and very current for the API world. So Trond, take it away.
Thank you very much. Yeah, it's a bit of a challenge. The last talk I did on this topic, I spent 2 hours. Well, it ran for 2 hours almost. So squeezing that into 20 minutes is going to be hard. So we're going to cover a lot of ground here today. Hopefully not too much, so you get overloaded. It's late in the evening, and you probably have had a long day, all of you. I hope you enjoyed the conference so far, by the way. So we're going to cram a lot of stuff into this, and I talk fast and there's a lot of slides, so hopefully you get some out of it. And I suspect for many of you this is a new topic, especially if you look into the title here. I guess you all know modularity, so that shouldn't be any new, but the open system may be a new concept. So but hopefully I'm going to be able to convey that at least, given that you know what modularity is, so you don't have to explain that too much either. But I'm still thinking we're going to start there, though, because complexity, looking how complexity and also then open system, how that relates to modularity is sort of given the topic here. But also, we also know that the go-to tool for solving complexity is modularity, that we try to break up stuff into manageable chunks. Eating the elephant, so to speak, is a common term, right? So just to give a heads up, the definition I'm going to use for what a module is, or a modular system is a system that's decomposed into semi-independent parts that are hidden behind abstracted interfaces. So that should be a common way of looking at things. In this group, it should be fairly obvious. But as I said, I'm going to take a little spin on it and see how does open systems ideas fit in here? How can it affect the way we look at the modularity in general? And just a heads up, when I'm saying system, I'm going to do a lot of system and system thinking and all those terms today. You don't necessarily have to understand the details of it or understand the concepts or even the technology, also the techniques or all that stuff. It's look at it as a way of framing things, another viewpoint, if you like. So you view things differently when you use this setting. Because I think we are generally working in systems that are open, and with that I mean it's open to the environment, exposed to the environment, so affected by the environment. And it's that setting that gives us all the complexity that we encounter. And I think we encounter complexity all the time. For some weird reason, when we get to work, we stop thinking complexity and then want to control everything. Just an illustration is having a kids party. I don't know if any of you have had that, but I sure have. And have sort of big plans of how the party should be. Sort of 15 kids coming to the house. There was 5 or 6 something. They were even younger sometimes. And they had the base layer plans and had brilliant ideas how this should look. And the second that the kids enter the house, the plans goes out the window literally. And then from then on, it's just basically damage control. So I mean, we live in this kind of complex situation normally in normal life, just driving to work and driving a motorbike or whatever it is. So open system is actually the norm. The complexity or given by the open system is norm. But I think we still try to reduce this when we start working on things. We start to reduce it and then try to close it, as I say. And with that, I mean we remove the environment all together. Then. So I think we try to manage complexity with classical thinking. We reductionist linear thinking, basically. Why we do that? Could have been that we have sort of had that show education. At least most of us probably come from a STEM background. And also when we do modularity and coding, of course, you have to reduce it down to a closed system because you don't want to create a program that can randomly change. So you want. I mean, we love the rules, but how can we then balance these two forces, if you like? So let's start looking at systems then. I'm going to use this illustration a lot here. It's just a set of cogs, and it's just to illustrate where we come from. Actually, yeah, where we come from, because you probably heard the Newton's clock. where they actually viewed the whole universe as a clock. So it was absolutely predictable when everything was going to happen. It was completely deterministic. And I think that still sort of lingers, the machine model, that we assume that we can, there is the determinism and predictability in anything. We do that, that sort of, we don't like uncertainty. That is something that is common to humankind. So I think we generally assume that the whole of a system is the sum of its parts. Like, for example, this simple illustration of the cogs. Yes, we see the cogs and we understand how the whole. If we turn the one cog, we're gonna, okay, we have to look at it a little bit, but we're gonna understand what's gonna happen at the other end of the whole system, how it's gonna play out. But with complexity, that's when things get really interesting. Is that because parts change in real life, they don't stay stable over time. So they are known, and often they change in a very unpredictable way. So that creates a huge amount of uncertainty. And actually then it moves from being a complicated system to a complex system, because we can't predict what's going to happen. In our daily work, or maybe for you in the API crowd, that would be like, for example, changing requirements, for example, or there's a sudden change in interface because somebody had to do something, and then suddenly the interface changes and everything breaks and all that stuff. But also when we do make changes to our system, also that system, then the whole space changes because of that change. So you can have side effects and all that stuff. And also, of course, like this beautiful new cog illustrate is that you can also see a situation where you have where people do local optimizations that don't necessarily increase the overall performance of the system. Actually, a system thinker would say that if you locally optimize a part, your system is not going to work better. Actually, it's going to work, probably behave worse. Even if you optimize all the parts, your system is not going to work any better. Actually, that's it is rather counterintuitive, but maybe you get the idea in this talk. A good example of a local optimization could be, for example, if one team wanted to go full hypermedia, go REST level 3 rigid maturity model, and the rest of the teams are satisfied with JSON or HTTP. Of course, that's going to change some conflicts between the teams if they are actually using each other's APIs. Or if one team decides, no, we're tired with this RPC stuff, we're going to do async now, events everywhere and stuff like that. So all these things, a local optimization can then affect the whole and probably even take it all the way down. But that semi-independence that we're seeing here, that is actually something we want. We want teams to be able to maneuver in autonomously, right? To have an autonomous team all the time. So we don't want to remove that. We don't want to constrict it too much. So that's sort of the balance that we're going to look more into later on. But what we're coming at, as I said, we frequently assume that a whole is the sum of its parts. But what you're seeing here, when things change and there's a lot of interaction, actually it's not. The whole is then larger than the sum of its parts. And why is that? So then we're going to do some system thinking one-on-one here. So I'm going to reach out to Mr. Russell Aikoff. I notice Mark mentioned him at the second talk today. He's a well-known system thinker, and he has this definition of a system, which is like this: is that a system consists of 2 or more parts. That's kind of obvious, but it should satisfy 3 conditions. The first one is that each element affects the behavior of the whole, and that this illustration shows that clearly. Like any change to one in the system is going to affect the whole. Number 2, the behavior of the elements and the effects on the whole are interdependent. That's a bit of a tricky one. It took me some time to understand it, but what is basically but just listen to the interdependent part. That is sufficient. So every part is dependent on every other part, and those dependency on the other parts are also dependent on the whole. Then, so everything is connected. Everything is like a view. But he also has a third one that he says that you can't create a subgroup, independent subgroup, because if you have a subgroup that's independent, you actually have a new system. It's not part of that overall vision system anymore. So it has to be part of that. But that also means that you have a hierarchy of systems, ideally. And Aikoff also is well known for having this brilliant quote that I see many use, is that a system is never the sum of its parts. It's a product of their interaction. I think even Mark referred to that earlier on. Another definition of a system which I like, which is going to take us to a different direction, is here from Donald Mellows, a well-known system thinker, as he was mainly working in the system dynamic space, so computers and systems. That's good. But what you're saying is that a system, it's a set of interrelated elements organized to serve a particular function or seek a particular goal. And that it's an interesting aspect. But then a system is not just sitting there. It's not it has a goal. There's something that we want, that the system itself wants to achieve, a function or a purpose. And this is interesting. There's a difference between a purpose and a function, and let's see why that is, because this is really turning into an interesting aspects. Back to Akoff again. He was a brain system thinker. So system type. So he described here in this book, and this is just a collection of his work. But so I don't remember the papers actually, but it is in his book anyway. Then he describes 4 system types based on their purposefulness. So if you look at the first one, the most basic one is the deterministic one. Here you have parts that have no purpose, but a whole doesn't have a purpose either. So your computer, your car, whatever it is, that is mechanical. And deterministic, as we said earlier, that's what we solve things as. There's no purpose. There are definitely functions, yeah, sure, but there's no purpose. Then he has another level, which is called animate. And there the parts don't have any purposes, but the whole has. And that would be you and me, for example. I would have a purpose. There's a reason why I'm here, because I want to share my learnings with you and all that. So I have a purpose for being here, right? And you probably have the same. But your lungs and your heart doesn't have a purpose. It just have functions within you. So they're part of the bigger system. And it also goes to another level, which is the social systems, where actually both the parts and the whole has a purpose. So if you are in a team, you as a person, of course, you have a purpose. We saw that previously. So this is a containment nested hierarchy actually of system types. But the team also have a purpose, I hope, that you work together for something that there is a goal somewhere you want to reach. And it also has the 4th one. I'm not going to get into that because that's ecological, where the parts have a purpose, but the whole doesn't have, like humankind. We're not going to look into that. But I think, I find that very often, when we create systems, when we create computer systems, we know it's social because we are people. We work in teams. We share code with people in the team, i.e., social, and we also write the code for other people. So it's social all the way through. But we like to reduce it to a deterministic system anyway. And that's fine, because then we're closing it. And so when we write code, we have to do that, unless we get some real AI someday. We have that's sort of what we have to do. But we have to then remember that we have consciously closed the system without knowing it. And with us in it, it's actually an open system. Again, we're going to see how that plays out. If we go back to this silly little model, you said that every part here then have humans in it. So parts have people. So then we should move, or at least that's what I think. We should move from thinking just the natural sciences way of thinking, but into social sciences as well. And this is the space I'm sort of exploring at the moment. And then we're into what Christoph said earlier in the introduction, that I'm looking into social technical system, because then every part has a social aspects and it has a technical aspects, and we can't divide the two. They are inherently linked. And this makes modularity a lot harder because it's not predictable anymore. So the connections increase exponentially because a lot of people, and they have a lot of needs, and the connections all over the place. But also the unpredictability, but people are highly unpredictable. So there's very little control. It's hard to have good control here. And also another one, the one that Akoff mentioned, is that they have purposes, right? And the purpose of the individual and the team doesn't necessarily align with the purpose of the team or the company as a whole. It should, but often it doesn't, right? So that's something, again, local optimizations and all that stuff. So this illustration that basically breaks down now, so I'm going to stop using it. So we're moving into what I refer to as an open social technical system, or I'm not the only one saying that, though, but I'm going to use it here as a term. And I think my modularity often fails because with this, we actually don't take this into account properly. So this team, for example, they are open to the system. They have a permanent boundary. They are not closed. They are open. If we close it, they are not giving autonomy to adapt, for example, right? Because we have created a shell for them. They just tack along with the code and doesn't care about what's outside. If you open it up, they have to learn to adapt. And the good thing is that people are really good at adapting. That's something that we are ace at least somewhat. But we often have, this is like an illustration of one team, but we frequently have more teams, of course. And this also increases the whole complexity of the system, because nobody's an island in an organization, in an organization that's a social system. So, sorry, one way. So if you go back to Akoff himself, what he's saying here is that an organization is a system, and the performance of a system depends more on how the parts interact than how they act taken separately. Again, back to the quote he said earlier, but product of interaction, stuff like that. And also reminded by something that Herbert Simon said about what modularity is. And he looks at modularity as a nearly decomposable system, nearly decomposable, which means that you can't separate the parts. They have some connections still. And those connections is what's interesting here. So how do you modularize then when we do that? How we define the balance between not too much interconnectionness and not too little, because then it's not a system anymore. So how can we build modularize and still have a coherent system, basically? A social technical system. So let's quickly look at that. I just illustrated 3 teams here. So modularity then means that we have to minimize the dependency between the teams, right? That's back to what Herbert Simon said. And so, but the important part is the semi. So they are not autonomous; they are semi-autonomous. They're semi-independent. So there's never no interconnection between the teams, because then it wouldn't be a system anymore. So we want to reduce the coordination cost. That's basically what you're saying, and making that line as thin as possible. So make the team more independent. And APIs are a great tool for doing that. Good APIs can disconnect the teams so they can work in separation. And also we want to avoid task-leaving teams, so that one team doesn't have to wait for another. And if you want that to happen, then we need to take a step further and say that teams should also own the whole task. They shouldn't be dependent on anyone else in order to fulfill their goal or mission or purpose, as we said earlier. So they need to own their own data, they need to own their own tools, and also their own processes. And that, of course, goes for every other team. And with this in mind, which means that we want the work dependencies and the coordination needs to be aligned, mirrored, or congruent is another term that's often used. So you don't want, if you want a tight interaction, you want that within the team and less outside of the team, right? That's basically it. But a team, now we're going to move into open system. And this is really interesting, again, something that I just recently discovered, actually, as a way of looking at what a system is that the teams are not a system, actually. They are part of an organization, which is the system. So they're just parts. The organization is the whole system. And it's the organization that's exposed to the environment. So the parts are, of course, via the whole organization, but they're not system in of themselves. And by thinking this way, you see that the team autonomy is actually nonsensical here, because you wouldn't have an autonomous team. That wouldn't make sense, because then it wouldn't be part of the system and wouldn't be part of the organization. So it's all joined together here. And this is actually something that I picked up from Andras Angial. So he has a different spin on what a system is. This is from I think this quote is from 1941, but he's worked on this since the 30s. And the quote here is that the biosphere, by the way, a term he coined, includes both the individual and the environment, not as interacting parts, not as constituent which have independent existence, but as aspects of a single reality which can be separated only by abstraction. So he's saying it that the system and environment are by design connected. You can't take them apart unless you abstract. And that's what I think we do when we close system. We abstract away the environment. We create something that really isn't there in real life. And that's what we do when we create programs, as I said earlier. So we shouldn't ignore the importance of this environment. I think we should actually embrace it. And I also say, embrace complexity then. But how can you do that? That's the big question. And now we're moving into action with some specific theory here. I'm running late, so I have to speed up more than I actually had. So this is Fred Emery's open system theory. I haven't got time to go deep into this, but if you're interested, Google it, and you get a lot of interesting papers on it. But what he defined was a set of 2 genotypical organizational design principles, DP1 and DP2, stands for design principles. And what you have on the left there is basically a hierarchy, where you want to de-skill people as much as possible so you can replace the parts. So yeah, I've got to mention that in order for a system to behave, or an organization to behave well, you have to have redundancy in the system, so you don't break when the stuff is leaving or something's breaking. So in the DP1, you want to have de-skilled parts so you can replace the part easily. That's the hierarchy. The one on the right is the on your right as well. DP2, there you actually you want to instead of de-skilling, you want to multi-skill people. So you want people to have more than one skill. So if one one person gets sick, the other one can cover that. And by doing this, you actually move the responsibility and the control and all that fancy stuff into the team. While in the DP1, you have to move it one level up because the parts doesn't have that knowledge. So you have that supervision. So just to illustrate a little bit differently. So DP1 is basically the hierarchy as we know it, while DP2 is this set of network of teams. There's still a hierarchy here, by the way, because there are some responsibility that's different in different teams. But there is no power hierarchy. There's somebody has a function here and someone has a function there. Maybe this is strategy and this is delivery. So they have different functions that I have in an organization, but nobody's telling anyone else what to do because that's part of the team. So we're moving from a hierarchy of personal dominance to a non-dominant hierarchy of functions, basically what you're saying here. But I think most organizations today are in neither of these, at least modern organizations like IT organizations. We are sort of in a mere weird transition between 1 to 2, and this is often referred to as laissez-faire. Where there is actually nothing. There's somebody thinks they have control in the hierarchy, the higher up. Yeah, we are control because we are in power and we are like position and all that. While the teams maybe further down try to be agile as much agile as possible and want to do whatever they want to do and just ignore those bosses. We're going to fix it anyway, right? So there is everybody thinks they're in control while none really is. And this is also problematic in the matrix organizations and all that. Quick mention what this means for APIs. Just a reference so you can look it up yourself. I haven't got time to go into them. But Matthew Rainbold wrote a good post on what API governance means, for example. Governance is DP1. Laissez-faire is when nobody's is controlling anything. And how can you then move it into DP2? Andrew Hamill-Law has also a post on fowler.com relating to this. How can you sort of do coordination across teams that are autonomous? Yes. Yeah, I was actually planning to go into some of the polarities there because you have a closed and open system. You have a complex organization and simple jobs versus a simple organization or complex jobs. But unfortunately, we haven't got time today. I'm already running over. So you better look up my other talks on this, or I could come back and do a more detailed talk later. So with that, I want to thank you for your attention. I hope some new ideas, at least, was what I came across. And I think the most important part is like the teams and the power to the people. So either you like John Lennon or Public Enemy, it's power to the people. Thank you.
Thank you, Trond. I think something because I had seen this before, but something that struck me now was the piece about purpose.
Yeah.
That basically when the traditional model, like when we didn't have APIs yet, we had to do human-mediated interfaces, where there was a human, like when there was an interfacing happening between teams, it always had to pass through a human, or it was team to team, but typically it was just team to human to team.
Yep.
And what you said about purpose, that hopefully there's alignment. I think that's where problems start, is when there is a lack of alignment of that human, like that human that is intermediating between teams, between complex systems that might have their own agenda, and then use the power the power they have over the team to do something that is not congruent with the purpose of the organization.
Exactly.
So that's There's
just a little because there's another one, because when we digitalize stuff, when we automate stuff, we actually try to then we had an open system, we close it by automating it, right? And then of course a lot of complexity then has to go away overhead, because we have done that. We have closed the system, so we have taken away the complexity. Hopefully that we create code that is not complex. So so the system is not able to cope with all that complexity. So it's got that's also my feeling with the hierarchy and both closed systems, is that they are brittle.
Yes.
It's hard for them to adapt because they can't, because they have been scoped in that sense. What is it they say about hierarchy? If hierarchy is going to absorb variance, you have to create more hierarchy. That's normally the way it's handled. So you resist it more and more. You don't adapt.
Yeah. I have a question from Lara. Can you recommend businesses today viable software to model such coordination between autonomous teams?
Good question. No, unfortunately, I can't. I think they had this whole open system thinking and complexity also really in IT is fairly new. Also there's little writing on this. For example, open system theory. There's no there are some papers and books, but they're nothing for our space, for example. So there's a lot of work to be done here, people. If you want to dig in. Well, unfortunately, no. Sorry. Not that I can pick up now anyway.
Like because we're looking for like a tool to do a non-strict a dynamic hierarchical model of the organization, so we can help the organization to evolve.
Exactly. So as I said, I ran a bit short here. So, but the open system theory, they have a set of concrete techniques that you can use to move from that hierarchy to a sort of a DP1 to DP2. There are techniques like there's somebody called the search conference, which is more about how you could adapt to your environment, and also participate design workshop. So the latter one is actually how can you set up these autonomous teams, that is and then the idea is that you do it participatively. There's nobody outside. There's no boss that tells teams how to organize. Everybody does it together, even including the boss.
Very, very, very interesting stuff. There's a lot more questions that I would love to ask. We're already running over. I think they'll forgive us because we're now on the stage. There's still some, but
the tail end of
there's nobody coming anymore. But I'd love to pick up this topic with you in a longer slot, in a longer format.
I hope so.
I want to ask about how to place boundaries and
how to find them. So I have another talk which I recently did at NDC Oslo, which is called "Good Fences Make Good Neighbors." I've done that a couple of times. So you can look that up. That goes more into modularity than open system, like I did here. So it's more as pure modularity talk, really.
Very good, Trond. It was a pleasure meeting you virtually.
Likewise.
And thank you very much for joining and for doing this talk and for sharing this with us here today. I hope it has excited and interested plenty other people into the open systems world.
I hope it triggers some ideas at least, and you can sort of start thinking. I don't expect everybody to say, now I understand open systems, because I sure didn't. Maybe I'm the dumb one, but...
It takes years, I think.
I think so.
It's just that's like all that hand waving.
Because not to use, I don't like the mindset thing, but it's a mind shift. You have to think differently.
And it just, what I found is that I keep falling back into the old
model. That's the comfortable one.
It's just the analytical mind never stops. And it's just we use habits and the use of existing models that we freeze in time as a heuristic to make life possible. And so it just to be constantly shifting your models, it just doesn't work.
No, you actually so sort of the idea of a mind shift is actually quite correct. I'm not sure if you're familiar with cognitive psychology, like the cognitive load theory. The team topology talks about that. But there are one element that we are kind of lazy. So if we know something from before it, we want to match it, the new information into what we have, because that's more efficient. So it's not lazy, but it's more efficient, and I think we do that a lot of times. So it took me quite some time to I think I understand it now. No, I don't. And then I'll start over again.
But it's like I think this is probably even how we can work in an environment, because we cannot match the complexity of the environments. So we have to make some sort of model and some sort of assumptions and simplification. And that's just the nature of the beast. And then some people have a more complex model than other people. But it causes a lot of problems today.
It does, sure does, yeah. So I think is in generally one thing we can do is just not assume that things are predictable, things are deterministic. They assume that you have to change constantly the team setup, the APIs that you create. Don't assume that you have version 1 and that's like solid for years. It's just not going to happen. So. Yeah. So find ways to be adaptive. Even open system theory talks a lot about active adaptation, which means that you, if you're very much in a turbulent environment, you want to control the environment somehow. So figure out how can you in your organization, if there's a lot of change in the APIs, can you get together as a group, say, okay, let's figure out how we can do this better for all of us instead of just one team, for example, and all that. Yeah. So you have to be more active. You can't just sit there and take it.
Thank you very much.
Yeah.
And talk soon.
Yeah, let's do. Thank you for having me.
Thank you.
Thanks.
Bye.